Hi everyone, today we are going to be solving linear systems using a new method, which is the elimination method. Just for a quick recap, we've already learned how to solve systems by graphing and by using the substitution method. So now we're going to talk about the elimination method, our third and final method. So for the elimination method, you're going to start with your two equations. So here we have x plus 3y equals negative 2 and x minus 3y equals 16. So your first goal is to find variables that have opposite coefficients. Opposite means one is positive and one is negative. However, the values are the same. So in this equation, for my x's, I see that the coefficients are both 1, so they're actually the same. But for my y's, I see that my coefficients are positive 3 and negative 3. So here we have a situation where our coefficients are opposites. Now, sometimes your coefficients won't be opposites to start, so sometimes you will have to multiply one equation or both equations if necessary. So once you have a situation where you have coefficients that are opposites, we're going to move on to step 2, which is to add the two equations vertically. So I'm going to put a plus sign here, and we literally add going straight down each column. So x plus x is 2x. Positive 3y minus 3y is 0, so those eliminate, which is why we call it the elimination method. And then negative 2 plus 16 is 14. And now that we have an equation with one variable, we can solve for the remaining variable. So here I see that we need to divide both sides by 2. And what we have left is x equals 7. So once you have solved for one variable, we're going to substitute it into either of our original equations to solve for the remaining variable. So let's say I decide to substitute it into the first equation. I'm going to zoom in a little bit to do this. So I'm going to replace my x with a 7, and then I have plus 3y equals negative 2. Now, I only have y, so that means that I can solve. So I'm going to subtract 7 from both sides, so 3y equals negative 9. And then I can divide both sides by 3, and I'm left with y equals negative 3. So I know that y is negative 3, and I know that x is 7. And so now all I have to do is step 5, which is to write our final answer as an ordered pair. So it's 7, negative 3. There you go. Okay, go ahead and pause the video and see if you can give this problem a try. Okay, so let's check our answer here. So you can see that we actually already have the scenario where we have opposite coefficients. We have negative 1 and positive 1. So that means I'm ready to add vertically. 2x plus 4x is 6x. 9 plus 21 is 30. And you can see that negative y plus y is 0. So those canceled out. Then just divide both sides by 6 and you have x equals 5. So then you can see that I substituted that into our first equation. I replaced x with 5 and then I simplified. And then I solved, so I subtracted 10 and divided both sides by negative 1. So my final answer was 5, 1. Now we're going to do an example where we don't have two equations that start with opposite coefficients. So you can see here that we have a negative 5x and a negative 5x. So those are not opposites, they're the same. So the first thing I'm going to do for this problem is I'm going to multiply one of the equations by negative 1 so I can turn one of the negative 5x's into a positive 5x. So you can multiply either equation. So let's say we choose to multiply the second equation. So I'm going to show that by writing my parentheses on both sides, and I'm multiplying both sides, every single term, by negative 1. So I'm actually going to rewrite both equations over here to the right. So my top equation stays the same. My bottom equation, negative 1 times negative 5x becomes positive 5x. Here, a negative times a negative becomes a positive, so plus y. And then here, a positive times a negative becomes negative 1. And now you can see that we have opposite coefficients and we're ready to add vertically. So you can see that we are able to eliminate our x terms, and then 2y plus 1y is 3y, and 13 plus negative 1 is 12. And now I can finish solving by using my inverse operation, and I get y equals 4. Now remember, once you have one of your variables, you still need to substitute it into one of your original equations to find the second variable. So let's say I choose to substitute it into my first equation. So my first equation was this, and I'm going to take out the y and substitute it with a 4. And now I can solve for x. So let's simplify this. 2 times 4 is 8. I'm going to subtract 8 from both sides. And last, I'm going to divide both sides by negative 5. So we're left with x equals negative 1. Now remember, our final step is to always write our answer as an ordered pair, negative 1, 4. And now we're done. So this was just an example of when you're not given opposite coefficients, how you can pretty easily create opposite coefficients by multiplying one of your equations. Okay, so go ahead and pause the video and give this last example a try. All right, so let's go ahead and check our work below. So if you look at the original equation, the original set of equations, we have the same coefficient here, but we want opposite coefficients. So I need to pick one of my equations and multiply that by negative 1. I chose to multiply my top equation by negative 1, giving me negative 3x minus 4y equals positive 6. So now I've created opposite coefficients for y, and that means that my y terms will eliminate, and I'm left with 4x equals negative 8, and then all you need to do is finish solving. So we get x equals 2, and then remember here I can substitute x equals 2 into either of my original equations. I chose to substitute it into that first equation, so you can see the substitution happening right here. X was replaced with negative 2, and then you just simplify and solve for y. So our final answer is negative 2, 0. So make sure to write it as an ordered pair, and then you're all set. All right, that's all for today's lesson. Thank you for watching.